Okay, first of all, there is a Common Core standard on this. It is FTF, which is functions, trig, and we're going to go 1, and it comes down to understanding radians as angles from the unit circle. Okay, that's our Common Core standard. What I want to do real quick is to go and take a look at our reading, all right? So go ahead and write that down. Everybody have that down. And then we're going to look at our reading, how our reading is going to connect us to the unit circle, all right? All right. First of all, let's take a look at number 1 and get an idea what this means. So when you do the inverse, like any inverse, it's an inverse function, okay? So when we do trig itself, normally we take sine of an angle and get a y value. Okay, I'll say it again. We take, normally, if it was sine, we take sine of an angle, we get a y value. For instance, sine of 60 degrees is square root of 3 over 2, okay? That's something we have done. Or sine of 45 is square root of 2 over 2. Or in radians, sine of pi 6 is 1/2. Now, to do an inverse, it's just the opposite of that. So if we have a y value, we'll get a corresponding angle. So sine inverse is saying find a y value of 1/2 and what's the angle, okay? If we have cosine, find an x value of square root of 3 over 2 and what's the angle. Okay, if we have a tangent, find a value of 1 for the tangent and tell me what the angle is, all right? These are a little harder, but we'll talk about this when we get there. So now, the thing is, how does this reading correspond to us? Well, the problem is, with sine of 1/2, I'm looking for a y value of 1/2. There's a y value of 1/2 here for sine, and there's another one here on my unit circle. There's two different values. Is the answer 30 degrees or is the answer 150? You could say both, but if this is a function, okay, if this is a function, you can't have two answers. It doesn't work. Remember, to have a function, you can't have two y values or two answers to one question. So it's either got to be 30 degrees or 150. Well, it's going to end up being 30. And if we go back to what we did on our graph, our inverse graphs tell us that we want, for sine values, is everything between, for angles, negative pi halves to pi halves for answers, okay? So what happens with sine is we are going to look for values in quadrants 4 and quadrants 1. I'm going to explain that pretty quickly, all right? So let's go back to this, right? Let's go back to the question. So we need a sine inverse of 1/2. I have two possible answers. So I'm going to tell you this real quickly. We always, remember this, we always take the one closest to the origin. I'll say it again. We're always going to take the answer closest to the origin. So we could either go to 30 degrees or all the way around 150. It doesn't make sense. We always take the one closest. So the answer really is just 30 degrees, okay? So theta is 30 degrees. Now in radians, which is what we really want, is in terms of radians, the same equivalent, radians is the degrees, is just the pi 6. So the answer that we really want is pi 6. That's the answer, right? Now, if we scoot to sine inverse of negative 1/2, we go to our unit circle, and remember, we always want to take the one closest. So you've got a negative 1/2 answer here and a negative 1/2 answer here. Okay, is the answer going to be 330 degrees or is the answer 210? Okay, listen carefully. Is the answer 330 degrees or 210? There's my negative 1/2, right? Negative 1/2. It's neither. It's neither. So I will not go all the way around to 330 degrees. Think about this. I want the one close to the origin. Am I going to journey all the way around to 330? No. I just go down to it. So the answer would be negative 30 degrees, all right? The one closest to 0 always. The one closest to 0 always. So the fastest way to get to this point, to this negative 1/2, is just go down to it. So to go down to it, it's a negative angle. So the answer is theta equals negative pi 6. Okay, now let's go back to our reading, okay? So you can see it. So in our reading, what we have is answers, remember these are my answers, from negative pi halves to pi halves, or in degrees from negative 90 to 90, which means that anything we find for sine in here, this is quadrant 4. It really is quadrant 4 because we have negative angles, all right? So on our unit circle, we find anything in here. So let's put it in our notes here real quickly. I want to put it in here, the domain. So sine inverse of y, because it's y of I, it's domain, okay? And we're going to put down, simply for right now, quadrants 4 and quadrants 1, okay? Which represents, from our graph, are really our negative pi halves to our pi halves.
Isn't that quadrant 3 or 4?
No, it's going to be quadrant 4 because I'll show you, Colby. It's these angles here, which is quadrant 4. Right? So we want to take any angle for sine in here, because what happens, we get repeat values. Okay? So our sine inverse domain is from negative pi halves to pi halves, right? Now, cosine is much easier, but let's finish this up. We're almost done. So sine inverse is square root of 3 over 2. We want to find a y value, and what's the corresponding angle? What's the angle? We're looking for angles now. So we go to square root of 3 over 2. Square root of 3 over 2 for sine is right here. There's my y value, square root of 3 over 2. The corresponding angle is pi thirds. So theta is pi thirds. Okay. So let's go back. Anytime you see the inverse symbol, you're going to find an angle. I'll say that again. Anytime you see the inverse symbol, you're going to find an angle. All right? And just like Jose said, we always find the angle closest to the origin, closest to 0, okay? And that actually just makes sense, doesn't it? So let's take a look at cosine. So cosine, to do cosine, we're looking for x values, right? X values. So if I want cosine inverse of the square root of 3 over 2, I'm looking for an angle where the x values are the square root of 3 over 2. So look at my unit circle. Here's an x value square root of 3 over 2. Here is another x value square root of 3 over 2. Both of these have the square root of 3 over 2. But which one's closer? Am I going to go to 30 degrees? Am I going to go all the way around to 330 degrees? I'm going to go to 30. I could go back to negative 30 degrees, but the domain for cosine is going to be quadrants 1 and 2. Okay, we're going to write that down in a second. So you guys all agree that this answer is going to be theta. The angle we're looking for is going to be my pi 6. There's my x value. I'm square root of 3 over 2. So it's just going to be pi 6, right? Now the domain for cosine, let's write this down. Domain for cosine inverse, is going to be quadrants 1 and quadrants 2. So when we're looking for any angle for cosine, we only take the angles in quadrants 1 or 2. I'll say it again. When I'm trying to find an angle for the inverse, for cosine, I only find the answers in quadrants 1 and 2. Here's why. If you look at the cosine values, watch the cosine values, they're all unique. Even though this is a 1/2, this is a negative 1/2. They're all unique. They're all unique, which makes it a function, right? If I take a look at these cosine values, I get repeats. And you can't have two answers to one question. It's not a function. If you go into quadrant 3, we get repeat cosine values, right? And again, same thing. You can't have two answers for one question. So where do we get unique answers for cosine? Quadrants 1 and quadrants 2. Okay? So let's finish this up. So cosine of 1, so we're looking for an x value of 1 in quadrants 1 and 2. That's right. It is right there. There's an x value. Cosine inverse of 1 is 0 radians. Theta equals 0, and that's 0 radians. Okay, that's not 0 degrees. It could be 0 degrees, but we're not going to do dumb degrees, right? All right? That should be a cosine. That's a typo. It should say cosine, not CO2. So cosine inverse of square root of 2 over 2. So we're looking for an x value in quadrant 1 or 2. An x value in quadrants 1 and 2. That is the square root of 2 over 2, and it's got to be right there. There's an x value, square root of 2 over 2, and the corresponding angle is pi fourths. Theta equals pi fourths. It is not hard. Now the tangents can be a real pain. So what I did while you guys were reading is I put the tangent values on my unit circle. And you might want to do the same thing. Here's all the tangent values. So on the outside of my unit circle, to make it easier for myself, because I'd have to think, okay, what a y over an x for tangents, a little bit difficult, so I put them on my unit circle. And I put them in a different color, so I'm going to put my tangents in, how about fuchsia for me?
Fuchsia.
So this is 0, that's my tangent value. This is going to be the square root of 3 over 3 on my unit circle. This is 1. This is the square root of 3. These are my tangent values, so I don't have to always go back and think, okay, this is my y over x, what's that going to make? I'm just going to give you the tangent values on your unit circle, okay? Tangent value here at pi halves is undefined. This is going to be a negative square root of 3 at 2 pi thirds, negative 1. So it's handy to have the tangent values on your unit circle because then you can just find them. I'll show you why in a moment. This one's going to be a negative square root of 3 over 3. This is 0 at pi. This one's, yeah. Yeah, sure. There they are. There they are. Okay. So there's the quadrants 1 and quadrants 2. So all I did is I just went through real quick and went the y over the x, what is that fraction? The y over the x, what is that fraction? The y over the x, what is that fraction? The y over the x, what is that fraction? The y over the x, what is that fraction? I just did those for us so that we didn't have to do as much work. So if the units, if they're on the unit circle, it makes it easy, okay? You guys remember how Mr. Birch had that chart? Anybody? No? Or Miss Downs had that chart, maybe. This is the chart.
We don't remember.
That's okay.
I have that chart mentioned.
Square root of 3 over 3. Now it might, right? Now it might make some sense. Positive 1. Square root of 3.
That's what I said.
Undefined. Negative square root of 3. Negative 1. And a negative square root of 3 over 3, okay? So there are all the tangent values. So these are the tangent values, but they're on the outside of the unit circle, all right? Now, once you get those...
Flip the fourth quadrant with the
Sure. Yeah. And there's a reason why. Because of all the triangles you draw in there, Colby. All the triangles you draw, these are just the flips of the triangles. Remember how we drew all the triangles in? These are all the flips of all those triangles. There, okay? So now, let's check it out. Let's see how this helps us. So, tangent. So we're looking for a tangent value. Looking for a tangent value of 1. Jose. So, Jose, find a tangent value of 1. Now, I just gave it to you. Where is it?
It's right there. Pi fourths.
It is pi fourths. It's also at 5 pi fourths, right? So obviously, which one are we going to take? You're going to take pi fourths, right? So theta is going to be pi fourths. Tangent inverse of negative 1. Let's see where it is.
Negative pi fourths.
Yes, totally right. You are ahead of me. I like that. Okay, it's either, you ready? It's either here or here. Okay, Quinn, which one is it? Yeah, no clue. It's neither. It's neither. You know why? I either have to go this distance, which is okay, or I got to go all of this distance, right? Or I can just go down to it, which is quicker. You always want to go the closest to 0. So you can either go all the way here to negative 1, you can go all the way around to negative 1, or you can just go down to it, which makes it negative pi fourths. So theta is negative pi fourths. So that means, let's talk about the domain. So the domain of tangent inverse is found, again, it's going to be in 1 and 4, just like sine. It's going to be in quadrants 1 and quadrants 4. So when you go into quadrants 4, you're going to get negative angles. I'll say it again. In fact, I'll write it down. Quadrant 4, you're going to get negative angles. So So when you go into quadrant 4, you're going to get negative angles because that's the quickest way to get there, is to go down to it, do a reverse rotation, rotate down to it, so rotating all the way around. It actually makes sense. So if you need to get to the closest value from 0, the closest value is just to go and rotate down to it, which makes it a negative angle. Does that make sense? So going all the way around, which would be silly, just rotate down to it. And that's why the domain is the way it is. Okay, now secant, cotangent, and cosecant. These are not on the unit circle. So, oh, I'm almost done. Sorry. How about this one? What do you guys, did you get this one yet? It is pi thirds. And it is right there. There's a tangent value of square root of 3 over square root of 3, which is in quadrant 1, pi thirds. Okay. Now, these are a little bit different. So what we're going to do on these is we're actually going to have to rewrite the question. Okay. Now watch how I do this. Watch carefully. This original question says I've got a secant of some angle equals 2. Okay. There's a secant. I want to find the angle. So I rewrite the question. The question really is the secant of some angle equals 2. Okay. I can't draw the secant, the cosecant, the cotangent. It'd be way too crowded. So, and we don't use these that often. So how does this work? Well, we know that secant is the same thing as 1 over cosine. Okay. So we're going to change it to its cofunction because secant is not on the unit circle, or not easy to find on the unit circle. But if I rewrite it as 1 over cosine, then I can do my little flippy floppy and say cosine of theta is equal to 1 over 2. And then from there, I'm looking for really some cosine, some x value of 1/2. It's got to be right there. Pi thirds. Okay. Cotangent. Square root of 3. Okay, again, we do not have a cotangent up there, but we can rewrite this as tangent of some angle equals the square root of 3. That is the question. Oh, I wrote that wrong. I'm trying to get this done so I can go next door. Forgive me. Cotangent of some angle equals square root of 3. All right. So cotangent is the same thing as 1 over tangent, right? Flippy floppy. Tangent of theta is equal to 1 over the square root of 3. That's not on the unit circle either, but if I rationalize it, right? Square root of 3, square root of 3. I'm really going to get tangent of theta is equal to square root of 3 over 3, and that is on my circle. Tangent value, square root of 3 over 3. It's right there. It's pi 6, isn't it? It's right there at pi 6. Last one, I don't think I'll do the back, only because I got to go next door. But let's do this one. Cosecant is not on the unit circle, but sine is. So if I go and change it to cosecant of some angle, it equals this 2 square root of 3 over 3. Sine is on the unit circle, so it's 1 over sine of an angle. Change sine, flippy floppy, sine of some theta is equal to 3 over 2 square roots of 3. And again, if I rationalize this, right, square root of 3, square root of 3, I'll get sine of some angles going to be square root of 3 over 2 times 3, okay? So what happens is if we get 3 square roots of 3 over 2 times 3, the 3's cancel. We're left with square root of 3 over 2. And that is on the unit circle. For a sine value, which is your y, a y value of square root of 3 over 2 is at pi thirds. Okay, I need to go next door. I will talk. The calculus is super easy. You just have to make sure you're in the radian mode. But I need you to do this. All right? And I'm going to go next door and check on those guys.